Howdy, this is Varshini and my project partner Kailash Venkatraman. We have worked on design and analysis of 5 level 6 switch ANPC inverter for ECM 613 course project. The outline of presentation is mainly of objective introduction, 5-level 6-switch ANPC inverter, modes of operation and its modulation strategy, simulation results and conclusion and future scope. The main objective is to study the analysis and design of 5-level 6-switch ANPC inverter with different modulation techniques with switching operating at different frequencies. Here we consider level shifted sine pulse with modulation from the line frequency operator switches and hybrid modulation technique for fast switching switches on the commutation link. The main objective is to obtain the 5-level output voltages considering these two modulation strategies and the topology. So in modern power electric generation, transmission and distribution, DC to AC power conversion is very much important. So thus multi-level inverters has been developed for the cost benefit alternative to various prevalent inverter schemes devices that convert DC to AC. Multi-level inverters are the devices that are used to produce high voltage and high power outputs with improved voltage waveforms and lesser harmonic distortion compared to that of traditional two-level inverters. These also have benefits of decreased dV by dt, low voltage and current harmonic content, thus increasing the efficiency and high voltage working capability employing semiconductor devices with low voltage rating. These can be utilized in applications such as renewable energy systems, motor drives, HVDC transmission. This is the topology we have considered for 5-level 6 ANPC inverter. It is a 3-phase inverter, so it consists of 3 legs and of 6 switches with 2 commutating switches and 4 main switches. These 2 commutating switches are generally replaced by a diodes which are present in an NPC inverter. Because of these 2 switches, the voltage balance in the NPC inverter can be achieved easily compared to that of an NPC inverter. These are the switching sequences obtained for the single phase on the 2 legs. And we can see the voltage can be obtained in step format from positive to 0 to and negative. We have each voltage, positive voltage has 3 states, negative voltage has 3 states, and the 0 state has a 3 state. Here, entirely 6 switches are operated with different frequencies. 4 switches, S2, S3, S5, S6 are operated at line frequency. These are the main leg switches, and S1, S4 are operated with high frequency switches. These two are the commutating switches. Based on switching operation, this entire inverter operates in 8 modes. From mode 1, mode 2, mode 3, there is a positive voltage. And next mode 3, mode 4, mode 5 consists of 0 voltage, and mode 6, mode 7, mode 8 consists of negative voltages. Kailash.
So this is the design parameters for the 5-level 6-switch ANPC inverter. We can see that the input voltage, we have designed it for an input voltage of 400 volts, and in output voltage we'll be getting a 5-level 400 volt output for a power rating of 320 watts. We are switching, the switching frequency is 30 kilohertz maximum, and the line frequency which we have assumed is for 60 hertz, which has been designed for for USA. The DC link capacitance voltage, the minimum capacitance value, the formula is given on the right hand side, and we have taken the DC link capacitance of 2 microfarad. The modulation index MA, which is the ratio of the control voltage by the triangular voltage, is 0.9, and MF is going to be the ratio of the switching frequency by the line frequency, which is of 500. So now now for the commutating switches on the commutating leg, we are using hybrid pulse modulation technique, where in case of the hybrid pulse modulation technique, in order to achieve this particular signal, which you can see on the right hand side, we compare a square wave with a sine wave, and the output is basically the particular signal you are getting. And for different phases, for phase B and phase C, we'll be shifting this signal by 120 and 240 degrees respectively. And this, when it is compared, these signals, when they are compared with a repeating sequence of high frequency, which is of 30 kilohertz, you will be getting the gate pulses required for the switches S1 and S2, where S2 is complementary to S1, and hence it will be passed by a NOT logic gate for giving the gate pulse for that particular switches. In case of the main legs, which is S3, S4, S5, and S6 for one particular phase, we are operating at a low frequency, that is at 60 hertz line frequency. So in this case, we are using a level shifted sine pulse modulation technique. And in this case, the carrier wave is of 10 kilohertz, and we have 4 levels, which is from -1 to -0.5, -0.5 to 0, 0 to 0.5, 0.5 to 1. So these four levels, when they are compared with that of the sine wave, we get four output signals, and these output signals are given to the particular switches. And for different phases, we are shifting them shifting the sine wave by 120 degree and 240 degree. That is phase B and phase C respectively. And this gives you the output. So these are the simulation models which we have done on MATLAB. On the left hand side, you'll be able to see the overall ANPC inverter simulation. On the right hand side, you'll be able to see the hybrid modulation signal and how we are able to how we have achieved it and phase shifted it for phase B and C. Below, you can see the entire level shifted pulse modulation technique which we have used which has been used for phase A, B, and C. Now this is the output voltage which we have received. So we can see on the left hand side is the line to line voltage, line to line voltage, which is of a 5-level output, and phase to phase voltage over here of the 5-level phase to phase voltage, which also can be seen on the right hand side. You have the current waveform as well, which three-phase current waveform, and as you can see that there's a bit of harmonics, but this can be further removed by designing proper LCL filters, which we'll be designing in the future as well as a part of further studies. So as a conclusion, we are able to say that this 5-level 6-switch ANPC inverter has been designed and simulated with an input voltage of 400 volts, and we are able to achieve 5-level 400 volts output voltage. This has been achieved by a number of modulation techniques such as hybrid modulation and level shifted pulse width modulation techniques. Which the hybrid modulation is used for the commutating leg, and the level shifted pulse width modulation is used for the main phase leg. So we can see that this ANPC inverter is an extremely cost-effective inverter. It has a higher efficiency and a greater power density, and hence it is much more advantageous and has much more better control compared to that of a normal NPC inverter and level NPC inverter. And the most important thing is the number of the stress on the voltage, stress on the switches is going to be reduced significantly compared to that of a NPC inverter. Further studies, what we are planning to do is the DC link capacitor voltage balancing of the same, and as well as for n number of capacitors, are we able to balance the DC link capacitor voltages. And we will be able to see the references which are attached below for your perusal. Thank you.
Thank you.